right, so again, video 2 here for lesson 10.4 on inscribed angles. So as promised, here are your corollaries. So it says, first one, two inscribed angles that intercept the same arc are congruent, right? So we kind of talked about that if you have two angles that intercept the same arc, two inscribed angles, then they're going to be congruent. So in this picture here, right, our two angles are angle S and angle T, which both intercept arc RU. So based off arc RU, each of them is going to be half of that arc. Okay. So we take a look here at this. We'll do these Desmos tools real quick. So this is the first one. All right, so it doesn't give us the measure of this arc, but notice that the two angles are the same, and no matter where I move S2 or T2, right, they're still intercepting arc RU. If I move RU or R, notice that this would now be a 40-degree arc. They're now both 20. Okay, the second one. So now it talks about a semicircle. If you have an angle that inscribes a semicircle, then it's going to be a right angle. So in this picture, RS is a semicircle, which means that segment RS is a diameter. Yes? So we have a diameter here. Again, it's very important to identify diameters in your pictures. So this angle T is going to be a right angle because it's half of 180. All right, so let's go back to Desmos. Let's investigate this idea. So again, if I move T around, it doesn't matter where T is, as long as it's intersecting or it's inscribing RS, it's going to remain 90 degrees. Okay, and then the last one is the quadrilateral idea. So if you have an inscribed quadrilateral, right, in a circle, then the opposite angles are going to be supplementary. The state test loves this idea for some reason, so be aware of that, right? So the opposite angles are going to be the ones that are diagonal from each other, so R and T, and then U and S, right? They're not consecutive angles. So you notice 90, 90, 110, and 70. Again, it just so happens that those two angles are both 90, 90. There's no congruence. It's all about being supplementary. So I will move them around to show you that if I move R, right? If I move T, I don't know, maybe, I have to move those ones. There you go, right? So now we have 117 and 63, that's still 180, 95 and 85, that's still 180. So there are your corollaries, okay? All right, one more idea to talk about in lesson 10.4. Very similar to inscribed angles, you'll see. All right, so it says given chord FH and line HJ tangent to circle E at point H, what is the relationship between angle FHG and arc FGH? Right? So this actually, we're going to do another proof here. We want to compare the angle FHJ right here with this arc FGH right here. Again, notice they use 3 letters, so you know to go, it really should just be FH. But the G's there, so they put it. Okay? Now, when we do this proof, the one thing that they're going to have you use is this tangent idea, right? So the setup here is because HJ is tangent and this DH is a diameter radius, we know that this is a right angle and this is a right angle. So we're going to use that in the proof today. So this is back from, I think, lesson 10.2 on tangents. So be aware of that. Okay. All right, so let's start this proof off. Okay. So we are going to say, and I'm going to use blue, that angle DHJ is a right angle. And again, that is that tangent perpendicular to a radius idea. So we have a tangent perpendicular to a radius. Okay. So now, if we look at angle DHJ, it's broken into 2 angles, right? Those 2 angles are angle DHF, this angle here, I'm going to call that angle 1, and FHJ, this angle here, call it angle 2. So we're going to say that the measure of angle DHF plus the measure of angle FHJ, they're equal to 90, right? Because they make the right angle. They're complementary because of the right angle. Well, Now, angle DHF, this angle right here, I'll do it in blue, I'll do it in green, is an inscribed angle, right? H is on the circle, so it's an inscribed angle. Its arc is DF, so its measure is going to be half of DF. So we know the measure of angle DHF is going to be a half the measure of arc DF, right? That's the inscribed angle theorem, inscribed angle. And now we're going to take this out and replace it with this using substitution. So we have 1/2 the measure of arc DF plus the measure of angle FHJ equals 90. And that's just by substitution. And that's sort of like the first part of the proof, right? Notice that we have angle FHJ in this problem, right? Oh, I'm sorry. There's one more part. We're now going to get the measure of angle FHJ by itself by subtracting away the 1/2 measure of arc DF. So if we subtract that, so we get the measure of angle FHJ equals 90 minus 1/2 the measure of arc DF. And that's just the subtraction property of equality. And now we're going to stop there. And again, I want to focus on this, right? We have that angle by itself, which is the angle we want to focus on, right? So now the question is, how are we going to manipulate this to talk about angle F or arc FGH? So let's come up over here, right? So side note, right? So let's look at the measure of arc DFH. So DFH is going to be a semicircle because DH is a diameter, right? So we know, and I'll do this right here, the measure of arc DFH is 180 because it's a semicircle. Now, I don't know if we talked about this, but we can use arc addition, right? So this DFH is broken into two arcs, arc FD, which is one of DF, and arc FGH, which is our second arc, right? So I'm going to call it arc FH. So we know that the measure of arc DF plus the measure of arc FH is equal to the measure of arc DFH, which is going to be 180, right? This is arc addition with some substitution, arc addition, right? Because they equal this arc, but this arc is 180, right? So now if I get, again, this arc is FGH, right? So if I get that by itself, I can do subtraction. So the measure of arc F, I'll use GH because they do, but really it's just, oh, I'm sorry, never mind. We want to get DF by itself. I'm sorry, because we want to substitute it into here, and if we can substitute something involving FGH in there, then we have those two things together. So we want to get this by itself by subtracting the measure of arc FGH. So the measure of arc DF is equal to 180 minus the measure of arc FGH. And now we can take this out right here and replace it with 180 minus the measure of arc FGH. And now we have our two ideas together. So I'm going to do that up here, and then I'm going to erase this stuff. So I apologize. Actually, I'll do it right down here. Let's do it down here. So we know that the measure of angle FHJ is equal to 90 minus 1/2 times 180 minus the measure of arc FGH. And let me erase up here, and we'll go back to the kind of the very beginning here. And now it's just manipulation, right? Can we manipulate this to see what it gets when it's simplified? Sorry about taking so long to erase. Okay, that's good. So in red here, so we're going to distribute the 1/2, the negative 1/2. So we have this is substitution. I got lazy, right? I got lazy. This is subtraction property. This is substitution. Again, right here. So now we're going to distribute. So the measure of angle FHJ equals 90 minus 90 plus 1/2 the measure of arc FGH. And that's by distribution property. Oh, I'm going slow. Why am I running so slow? Sorry. And now here we can just simplify the 90 minus 90. That goes away. And we get that the measure of angle FHJ is equal to 1/2 the measure of arc FGH. And that's just by simplifying. And this is the idea that we want to learn. And again, it's the same idea as the inscribed angle theorem. This angle created by a chord and a tangent is still going to be 1/2 its intercepted arc. Okay, so here we go. So again, the measure of an angle formed by a chord and a tangent, tangent and a chord, so DE is the tangent, AE is the chord, is going to be 1/2 of its intercepted arc. So in this picture, again, AE is the chord, DE is the tangent. This angle is going to be 1/2 of this arc. Okay, to save some time, I'm going to skip the Savas introduction or Savas investigation. Okay, so last slide here on this video. So let's do this problem here. It says a director wants to position 2 cameras to capture an entire circular backdrop behind 2 newscasters. Where should he position the camera? So this is kind of a strange question, so I'll walk you through it. So basically what they're asking for is, can you describe the circle that they would need, okay, so that this camera could rotate and capture the whole backdrop, right? So describe the circle. So first off, we need to find the radius of this circle. So if you take a look at this backdrop, right, okay? So let's envision the circle, right? So here's the circle, that's the arc, right? Here's the circle. Okay, let's find the center, let's put the center of the circle right here, right? Let's say it goes to, there and there, the radii. Here's your arc. It is going to be a 90-degree angle here. And now we know that this chord right here that I just created, this chord is 16 feet wide, right? So the idea is, what would this radius be, right? Right here. Well, if I draw that part of the diameter perpendicular to that chord, it's going to bisect the chord into 8 and 8, right? And now, because this is 90, this angle is also being bisected. This is 45 and 45. This is 45 and 45. These are both 45, 45, 90 triangles, right? Side lengths, S, S, S squared to 2. So if this is S, this is 8. So if S is 8, we know that the radius is going to be S squared to 2, which is 8 squared to 2. That's our radius, right? And that would be in feet. And now we also know that this center is going to be 8 feet away from the set, right? Because these are both S's. So this is the other important point they want you to point out, is about where the center of the circle is located, okay? All right, so the answer here, and again, this is a strange question, but do it anyway. So the answer is, put the camera on any point of a circle with radius equal to 8 squared to 2 feet and center 8 feet from the midpoint of the set. Right, so again, if this circle represents that, they're saying you can put the camera anywhere on here. Okay, and because this is a 45-degree angle, we know, okay, so that's the part that I was trying to figure out. Because this is a 45-degree angle and this is an inscribed angle, that's why we knew that this arc measure was 90. So that's the part I kind of just assumed. So sorry about that. This camera has an angle of 45 degrees that it opens up to, and it's going to be an inscribed angle going on this circle. So because of that, we know the arc was 90, and that's why this central angle was a 90-degree angle. So sorry to kind of go backwards and explain, but that's the clarity. Okay. And there we go. Cool beans. All right, so great. So hopefully you can solve some problems involving inscribed angles and these corollaries in your practice problems. Really good problems. All right, good luck.